Alright, so let's take a look at how to do Lewis dot diagrams. The reason why we talk about Lewis dot diagrams is because whenever we look at bonding, it helps us to explain the ionic and covalent bonding models. The octet rule states that elements want to have a full valence shell with 8 electrons, with the exception of a few elements that like to have duets. The full shell is accomplished by bonding. So we use the electron dot notation or the Lewis dot diagram to show how the valence electrons are present, because those are the ones that will participate in bonding. So for our Lewis dot diagram, if you remember these from before, we have the element symbol, which is found in the middle, and then we put the valence electrons around the outside. We, in general, fill the electrons clockwise, one on each side, and we pair only whenever we need to. With nonmetals, those unpaired electrons would be used in bonding. Either they are going to gain electrons from a metal, or if they're bonding with another nonmetal, then those unpaired electrons will be the ones that would be gained, or rather shared in a covalent bond. For metals, the dots or the valence electrons is what will be lost in an ionic bond. So let's go ahead and take a look at some practice problems. So we will take a look at bromine, and bromine is going to be atomic number 17, so I included the noble gas configuration. You should be able to also do the electron configuration. For our valence electrons, what we have for bromine is that we have our valence electrons of 4s2 and 4p5, so there are 7 valence electrons. So whenever we do our electron dot notation, we have bromine, and then I normally start at the top, it doesn't really matter, but we go clockwise, so I'll have one in, oh, that one disappeared, so I have one in each spot, and then I double up or pair up only as needed. And so my unpaired electron, this one would have one unpaired electron, which would be used in sharing for a covalent bond, and then the element bromine would want to gain one in an ionic bond. So let's go ahead and do another example. If we look at lead, again, I put the noble gas configuration atomic number 82. So our valence electrons will be 6s2 and 6p2. And so for this, we have 4 valence electrons. And so for lead, which is Pb, we would have 1, 2, 3, 4. Again, we don't write something like Pb1212, and the reason why we don't do that is because looking at this, we see 4 unpaired electrons, and so it helps us to identify how it's going to bond more easily. All right, we'll do one last one. So we have potassium, and potassium is going to be atomic number 19. The valence electrons will just be this one valence electron. And you can put this anywhere around. We put the symbol in the middle, and then we'll go ahead and put our valence electron. If you have any questions about that, please let me know. All right, so I wanted to briefly discuss the activity that you will be looking at, which will be a simulation on ionic and covalent bonding. So this will be just an introduction. Some of it you might know, some of it you might not. This first part, background information, you should be familiar with. Practice drawing some Lewis dot structures. I will have this posted, but here is a link so that you can check those first 6 answers. Alright, so for the ionic bonds, you'll go to this link, which will bring you here, and the periodic table will allow you to kind of interact and practice and see like what are the compounds going to be formed. What I want you to pay attention to is this, and so the first example is sodium and fluorine, okay, and it's going to ask you what type of bond is this combination likely to form. So we have a metal and a nonmetal, so you should remember that that would be an ionic bond. If you don't, then it'll just ask you to do it again, and then it asks you, what do you think, how many of each atom will you need? Well, whenever we looked at sodium and fluorine, we have 1 valence electron, so it's going to lose that 1 and become positive 1. This has 7, it's going to gain 1 and become negative 1, so you would just need 1 of each to make a neutral compound. So I would select 1 and 1. Again, if you don't get it right, then you would just try again. What I want you to pay attention to is that it gives you the formula, so you shouldn't have to worry about that, but also just pay attention to what this looks like. So this is called a Lewis structure whenever it goes to the positive and negative, and it's showing you how the ions are. Keep in mind that there would be many sodium and fluorine ions that would make up the lattice structure for an ionic compound. So you'll take a look at ionic compounds. You'll be able to look at calcium and chloride together and kind of answer these questions here. And then you'll take a look at a few other ones in this table here, just to practice remembering what's the formula, what's the name of the compound. You can even test. You should be able to do this even without the simulation, but if not, the simulation is there to check. Then you're going to take a look at covalent bonds. So this first link will take you through here, and there will be just a little tutorial and simulation that you can click through, and you should be able to see kind of what's happening to the electrons. So pay attention to where the electrons are at in the covalent bond, and then answer the questions on the worksheet as you go through. The next part will take you back to the link that we used before. So we'll take a look at diatomic molecules, which have two atoms bonded together, and then you'll also take a look at atoms that form covalent molecules. After you do that, you'll do a little summary, and then just test your knowledge of what's ionic and covalent bonds and review that information. We'll do one example here for the diatomic, so let's take a look at chlorine. So if we do chlorine and chlorine, so we have two nonmetals. They are going to form a covalent bond, and because they both have one unpaired electron, you'd probably expect that they would just share that one, and so we'd have a 1-to-1. Again, it's going to correct you if you don't select the right things. Take note of the formula, take note of the geometry, which we will be getting to, and then pay attention to what the structure is that's going to be formed. This is called the Lewis structure right here, and this shows how the electrons are shared in the molecule. If you have any questions as you're going through, obviously reach out and let me know how I can help.